AI moved fast again today, and if you blinked, you missed 3 headlines. This is Tech Roundup on the AI Verge, your daily dose of what actually matters in AI minus the hype. Let's get into it. So I want you to imagine waking up tomorrow morning and the world around you is just subtly, like almost imperceptibly alive.
Right, like your house is actually paying attention to you.
Exactly. You walk into the kitchen and your smartphone physically turns on its wireless charging base. Like the screen actually rotates to track your face as you start talking.
Which is such a wild image, just your phone following you around the room.
It really is. It keeps you perfectly in frame while you're, just pacing around pouring your morning coffee. And then over on the counter, there's this completely enclosed robotic appliance.
So the cooking bots?
Yeah, it's quietly, autonomously dicing vegetables, adjusting these complex heat curves, and basically cooking a full meal that you essentially just queued up like a Spotify playlist before you went to sleep.
Just hit play on dinner?
Exactly. And then, say you spill some of that coffee on the hardwood floor, you don't press a button on a vacuum, you just point your finger at the puddle and say, "Clean here."
And it actually knows what you mean.
Right. This vacuum, which is equipped with like 5 distinct camera lenses, just wheels out from under a cabinet, visually locks onto the exact spot you gestured toward, deploys a mop, and just handles it.
It's the frictionless future we've been promised by sci-fi for literally decades.
It feels like it, right? But the reality of how this is actually happening is, it is incredibly messy.
Oh, completely chaotic.
Like the tiny, high-performance gears making that phone smoothly track your face. There is a very real chance they were covertly smuggled into the country in some robotics engineer's checked luggage.
Just hidden right under their T-shirts.
Literally tucked next to a toiletry bag on a commercial flight out of Shenzhen.
It is a phenomenal juxtaposition, honestly, because we are living through the absolute peak of this consumer-facing, polished, physical AI.
Right, the glossy stuff.
Exactly. We're talking about machines seamlessly integrating into the most intimate spaces of our daily lives. Our kitchens, our living rooms, our pockets.
But the back end is a totally different story.
It's a disaster. How these machines are actually built, how they are trained to understand what a coffee spill even is.
And how they're regulated, which is a whole other thing.
Right. By governments that are just in full panic mode. It's in a state of total, unmitigated chaos.
Yeah.
We're watching an industry move at a velocity that is literally outrunning international supply chains.
Oh.
It's outrunning corporate risk models, and honestly, the very concept of human oversight at this point.
And that friction, between the glossy product and the chaotic back end, that is exactly what we are diving into today. We are looking at this massive stack of recent sources detailing the aggressive acceleration of physical AI.
Which is happening so fast right now.
It really is. So our mission today is to just cut completely through those highly edited promotional videos. You know the ones, right?
Oh, yeah. Your humanoid robots doing perfectly choreographed backflips on a padded mat.
With the dramatic music playing in the background.
Yeah.
We are bypassing all that hype to figure out how these machines are quietly taking over our infrastructure.
And the geopolitical absurdity of how it's actually put together.
Exactly. Plus the absolute regulatory nightmare they're creating for compliance teams all over the globe. So let's start right inside our homes, because the most intimate piece of technology we own is undergoing this radical shift.
You're talking about the smartphone.
Yeah, the smartphone. For the longest time, this market has felt, entirely stagnant. We've essentially been buying the exact same black glass rectangle for a decade, right?
Comparing for a slightly better camera lens every year.
Exactly. But Honor is launching something in China right now that completely shatters that mold. They are calling it a literal robot phone.
And, this isn't just a clever marketing term for some new software feature. The hardware itself is fundamentally different.
How so?
Well, this phone features a built-in motorized gimbal system.
Okay, wait, a motorized gimbal inside the phone?
Inside the phone. It has the mechanical ability to autonomously track subjects for cinematic shots. It physically reacts to its surroundings.
That's crazy.
And they claim the conversational AI is sophisticated enough to hold real dynamic conversations with the user while the device physically moves to, maintain that interaction.
Okay, I have to stop you there and push back on the practicality of this. Because a motorized gimbal built into a phone, moving parts and the lint-filled high-friction environment of my jeans pocket usually do not mix well.
A fair point.
Like, is this actually a useful tool, or are we just looking at a highly fragile gimmick? Because from an engineering standpoint, introducing delicate mechanical actuators into a device that people drop on the pavement on a weekly basis, that seems like a warranty nightmare.
It does, and that is the natural skepticism everyone should have right now. The durability of consumer robotics is always the very first bottleneck.
Right, because things break.
Exactly. Introducing mechanical failure points, gears, tiny servo motors, hinges into a high-abuse consumer device is incredibly risky. But if we look past the immediate novelty of, taking a smoother video,
Okay.
the gimbal isn't actually about the camera at all.
Wait, what is it about then?
It's about data collection and spatial reasoning. For that device to track you autonomously as you move around a kitchen, it can't just look at you. It has to constantly map its physical surroundings in real time.
Oh, I see.
It has to understand depth, the location of obstacles, the velocity of your movement. It is practicing constant, localized spatial reasoning.
So the phone is essentially learning the physics of the room.
Precisely. By giving the AI a physical neck, so to speak, the ability to turn and pan, you are providing it with embodiment.
Embodiment, that's a great word for it.
Historically, our relationship with our devices has been entirely one-way and static.
Yeah.
You pick up the phone, you manipulate it, you set it down. It is just an inert slab of glass waiting for your command.
Right.
But when a device can physically orient itself towards you, it changes the entire psychological interface. It creates a sense of presence.
It feels like it's listening, not just recording.
Yes. And more importantly, it serves as a massive distributed testing ground for the company. They are deploying millions of these devices to train their AI models on how to interact with the physical world on a global scale.
Okay, that makes a lot of sense. The hardware might be fragile, but the spatial data it feeds back to the cloud is bulletproof.
Exactly. It's an intelligence gathering tool.
And that spatial reasoning is bleeding into everything else too, especially the most labor-intensive room in the house, which is the kitchen.
Oh, absolutely.
I was so fascinated by the deep dive in our sources on this company called Pasha. It was founded in 2017 by Gupta, and his core premise was super simple. People want home-cooked meals, but they do not want to spend an hour doing the labor.
Which is very relatable.
Highly relatable. So they've dubbed this countertop robot a coffee machine for food.
Which, by the way, is just a brilliant framing device.
It really is.
It immediately demystifies the technology. You don't need a culinary degree to use a coffee pot machine, and Pasha wants to apply that exact same frictionless experience to a complex dinner.
Exactly. So the user just adds pre-measured ingredients into these specific hoppers. They select a recipe on a screen, and the machine physically executes the cooking process.
This takes over completely.
Yeah, it controls the thermal dynamics, it stirs, it incorporates ingredients at the exact right second. And the central metric here, the thing that really caught my eye, it slashes kitchen prep from an hour to about 10 or 20 minutes.
Wow.
That is a 70% reduction in the time it takes to feed yourself a fresh meal. But I really want to understand the mechanics here. This isn't like a robot with two arms flipping a pan, is it?
No, not at all. And that is a crucial distinction to make. What Pasha has done is prioritize function entirely over form.
Okay.
It does not look like a humanoid chef standing at your stove. It looks like a sleek, enclosed appliance.
Like a really fancy bread maker or something?
Basically, to actually cook a meal autonomously, the system relies on incredibly precise microcontrollers. It uses induction heating to manage temperature curves with a level of precision that a human on a gas stove could literally never achieve.
Because it's adjusting heat by the millisecond.
Exactly. It uses automated dispensing mechanisms that have to account for the viscosity of different sauces or, the density of different vegetables. The engineering challenge is actually immense.
I can imagine.
Think about it. How do you ensure a sticky teriyaki glaze drops into the pan at the exact moment the chicken reaches a specific internal temperature, and do all of that within a closed system?
Right. It basically has to translate a culinary concept like caramelization into a strict mathematical thermal curve.
That's exactly it. And when you solve that mathematical problem, think about the behavioral and sociological shift that causes.
Yeah, how it changes our routines.
For centuries, human beings have structured their entire evenings around the ritual of meal preparation. It is a core pillar of domestic life, but let's be honest, it is also a massive unpaid time sink.
Oh, completely.
So by reducing that friction by 70%, this technology is not just producing food, it is quite literally manufacturing free time. It is giving families 40 minutes of their lives back every single day.
I love that idea of manufacturing time. It really reframes what these devices are actually doing. But, the transition from dumb appliance to spatial awareness isn't just happening on our countertop.
No, it's hitting the floors too.
Let's talk about the floors. We all know robotic vacuums. They've been around for years, mostly employing what I like to call the blind bumper car method,
Yes.
driving around aimlessly.
Right. They drive until they hit a couch leg, turn 45 degrees, and just keep going.
Mhm.
But our sources detail a company called Matic that just pushed a massive update they are calling Qs.
This is a huge leap forward.
It really redefines the category because the Matic vacuum uses 5 onboard cameras, not those VR bumps, but actual optical lenses, and the interaction model is wild. You can literally point your human finger at a spill on the floor, say the words clean here, and the robot handles it.
The technological leap from a tactile bump sensor to full semantic understanding is just staggering.
Semantic understanding meaning it actually knows what it's looking at. It's exactly. Let's break down what is actually happening in those few seconds when you point your finger. First, the robot's cameras must capture your physical form.
Okay.
Then, the onboard computer vision model must run a skeletal tracking algorithm to identify your arm and your index finger.
Just to know you're pointing.
Right. Then it has to calculate the vector, basically the invisible line extending from your finger down to the floor. Next, it analyzes the optical data at the end of that vector.
So it looks at where you're pointing.
Yes. It uses segmentation algorithms to differentiate between the normal pattern of your hardwood floor and the anomaly, which in this case is the coffee spill.
Wow.
And finally, it has to decide, based on the visual properties of that spill, whether to deploy a dry vacuum or a wet mop and chart a path to that location without hitting your dog on the way.
And it does all of that locally, because waiting for a cloud server to process all that high-res video while the coffee just seeps into the wood seems terribly inefficient.
It does it all locally, yes. And that is the magic of edge computing.
Edge computing.
Right? Processing data on the device itself. The processors on these localized machines have become so powerful that they don't need to send the video to a server farm to understand it. They're processing heavy neural networks directly on the device. It is genuinely seeing and understanding the nuanced context of your living room in real time.
That is brilliant engineering. But here is the part of the source material that really stopped me in my tracks, and it's on the business side of things.
Pricing model.
Yes. Matic is delivering this massive software capability, upgrade the Q's pointing feature for free to existing users over the air. But starting in September, the price of the actual physical hardware, the vacuum unit itself, is jumping from $1,245 to $1,495.
A $200 price hike.
They are raising the price of a physical product that has already been manufactured by over $200 simply because the software inside it just got smarter.
Which completely upends 50 years of consumer electronics economics.
Right.
Traditionally, physical hardware depreciates the literal second you open the box. The plastic ages, the battery degrades, the motors wear down. It is a depreciating asset.
It's like driving a car off the lot.
Exactly. But in the physical AI era, we are seeing the exact opposite. The hardware is essentially just an empty vessel. It is just a delivery mechanism for the software. As the AI models become vastly more sophisticated, the physical capabilities and the utility of the robot actually increase over time. The machine you own today is objectively better and more capable than the machine you bought 6 months ago, despite the physical wear and tear.
That is so counterintuitive. It's like buying a Toyota Corolla, and then 3 years later, a software update turns it into a Ferrari.
That's a great way to put it.
But wait, doesn't the physical reality of a cheap plastic wheel or, a degrading battery eventually bottleneck the brilliant AI? Like, you can have the smartest brain in the world, but if the mop motor burns out, the price shouldn't go up.
You've hit on the ultimate tension point these companies are going to face. The software can scale infinitely, but physics always wins eventually. Batteries die, gear strip.
Yeah.
But Matic raising the price is a deeply confident signal to the market. They are betting that their hardware is robust enough to support years of software evolution. They're basically telling the consumer, you aren't buying a static vacuum, you are buying a continuously upgrading intelligent platform that just happens to have wheels and a mop attached to it.
If people are willing to pay a $200 premium for a vacuum that can merely see their living room, imagine what a massive corporation will pay for a kitchen that never sleeps and never asks for a raise.
The scale is entirely different.
The financial incentives for this technology scale up exponentially, which brings us out of the home and directly into the commercial sector where things are getting aggressively disrupted.
Oh, the food industry is getting totally overhauled.
Yeah. Let's talk about the food industry at a macro scale. Our sources highlight a New York-based food hall chain called Wonder. They have deployed specialized robots capable of making 500 bowls of food per hour.
It's just an unbelievable volume.
500 bowls an hour. They tripled their kitchen's output, and they added exactly 0 new staff members to achieve it. And the market response to this, they just raised $650 million at a staggering $9 billion valuation.
Wonder is the perfect case study in how physical AI doesn't just improve an industry, it fundamentally rewrites the unit economics.
Oh, so?
Well, for decades, the restaurant business has been an incredibly brutal industry. You are dealing with razor-thin margins and massive, unpredictable variable costs.
Like ingredients going bad.
Food waste is a huge one, yes, and specifically human labor. Scaling a restaurant concept is a nightmare because training a constantly rotating cast of human line cooks to perfectly replicate a specific recipe across 50 different locations is almost impossible.
Right, somebody always brings the sauce.
Exactly. Wonder is entirely shifting the economic model. They are moving away from ongoing operational labor costs and replacing it with a massive upfront capital expenditure.
Meaning you buy the robots once and they never call in sick.
Precisely. You amortize the cost of the robot over millions of meals. But the truly disruptive part of Wonder's model in the sources isn't just the physical robotic output. It is the software layer sitting right on top of it.
The menu generator.
Yes, they're offering a $10 a month AI program that allows literally anyone to build their own custom restaurant menu.
I really want to dig into that mechanism because a menu is just, a list of ideas on paper. How does a $10 AI menu generator actually translate into physical robotic cooking instructions?
This is where we cross from culinary arts directly into software engineering. The AI doesn't just output a recipe that says a pinch of salt or cook until golden brown.
Because a robot doesn't know what a pinch is.
Right, those are subjective human instructions.
Right.
The AI translates the recipe into a deterministic code file. It defines the exact gram weight of the salt. It defines the specific thermal curve the induction burner must follow, mapping exactly how many joules of energy to apply per second to achieve the perfect Maillard reaction for caramelization.
Wow.
It dictates the exact torque and RPM of the robotic stirring arm.
So they've literally turned cooking into a software deployment. You write the code for, a spicy tuna bowl, you hit push, and a robotic kitchen in another state compiles that code into physical food.
Yes. They are democratizing the intellectual property of a restaurant, the conceptual design of the recipes, while heavily hyper-industrializing the physical output.
That is wild.
If the physical execution of a dish is automated and guaranteed to be perfect every single time, the human chef no longer needs knife skills. The chef basically becomes a software architect. Their only remaining value is the creative conception of flavor combinations.
That is staggering to think about. So the commercial kitchen is basically being conquered by these specialized boxes. But what about the factory floor? Because the sources paint a fascinating and somewhat conflicting picture of industrial robotics right now.
The warehouse space is a total battleground.
It really is. First, we have Agility Robotics. Their Digit V5 humanoid robot has just reached a massive milestone. It is now working alongside humans on factory floors without needing safety fencing.
We really need to pause and emphasize the significance of removing that safety fence.
Why is that such a big deal?
Because in the world of industrial robotics for the last 50 years, robots have essentially been massive, blind, incredibly dangerous kinetic weapons.
Right.
Think of a giant robotic arm welding a car chassis on an assembly line. We put them in literal heavy-duty cages with massive red kill switches. Because if a human worker accidentally steps into the predetermined path of that robotic arm, the robot does not know they are there. It will not stop.
It'll just keep moving.
It will simply crush the human with thousands of pounds of force.
Right, because they are just executing a blind, repetitive loop of coordinates.
Exactly. So for Agility Robotics to confidently claim that their bipedal humanoid can operate entirely without physical fencing, that means the machine has achieved an astonishing level of real-time environmental awareness.
It can actually see the humans.
Yes. It means the robot's onboard sensors, cameras, and processing speeds can detect a human stepping into its path and completely halts its own kinetic momentum in a fraction of a second. It means regulators and factory managers actually trust the machine's localized intelligence.
Which is a huge hurdle to clear.
Massive. The robot has transitioned from an isolated piece of dangerous heavy machinery into an active spatial coworker.
A coworker made of metal. But here is the massive conflict hidden deep in our sources, and I find this showdown absolutely fascinating. There is a deafening amount of hype right now surrounding humanoids, right? Robots that mimic the human form with 2 legs, a torso, 2 arms, and a head.
Is all anyone wants to fund right now.
Exactly. We have companies like Figure AI raising billions of dollars. And the sources point out that 3 of Figure AI's highly hyped humanoid robots recently ran for a combined 200 hours in a warehouse setting, and they managed to process about 1,250 parcels.
Which, from a pure robotics engineering standpoint, is a major feat.
Oh, sure.
Getting a heavy bipedal robot to balance, navigate a cluttered warehouse, identify a box, calculate the grip strength required, and move it without falling over is incredibly difficult.
I completely agree. The balance algorithms alone are a marvel. But then you contrast that with Shenzhen-based X-Square.
Right.
They recently live-streamed a raw challenge featuring their Walby system. And Walby is not a humanoid. It is a single, hyper-optimized robotic arm mounted to a station.
Just an arm.
Just one arm. In a single hour, feeding packages from a chaotic, messy pile onto a live sorting belt, that one singular arm sorted 1,816 parcels with 98% accuracy. Let me just frame those numbers again. 3 heavily hyped humanoids managed 1,250 parcels in 200 hours. One non-humanoid arm sorted over 1,800 parcels in a single hour.
And right there, laid bare in the data, is the great form versus function debate that is currently tearing the robotics industry apart.
I look at those numbers and I have to ask, are we collectively losing our minds?
In what way?
Are venture capitalists pouring billions into building a highly fragile, incredibly expensive Swiss Army knife that looks exactly like a human being when all the global supply chain actually needs to be profitable right now is a really fast, cheap, reliable pair of scissors?
That is the perfect analogy, and it gets to the very heart of the tension. You have 2 diverging philosophies right now. The first is general-purpose robotics, which is the holy grail the humanoids are chasing.
Okay, what's the argument for that?
The philosophical argument for the humanoid form factor is quite compelling on paper. If you look around you, the entirety of human civilization, the angle of our stairs, the shape of our door handles, the height of our kitchen counters, the layout of our factory floors, all of it was specifically designed to accommodate a bipedal creature roughly 5 to 6 feet tall, with 2 arms and articulated hands.
That makes sense. We built the world for us.
Right. Therefore, if you want to build a single robot that can seamlessly navigate and operate within any existing human environment without having to completely retrofit the building, the robot fundamentally needs to be shaped like a human. That is the long-term trillion-dollar vision, the ultimate skeleton key for human infrastructure.
Okay, I see the logic there. But what about the short-term reality?
The short-term reality, which the X-Square data brutally illustrates, is that for specific, repetitive commercial tasks, specialization absolutely obliterates generalization.
Because it's just faster.
Way faster. If your only operational goal is taking cardboard boxes from a messy pile and putting them onto a conveyor belt, a bipedal form factor is entirely unnecessary overhead.
You're just paying for legs you don't need.
Exactly. Why do you need complex balance algorithms, heavy gyroscopes, and 2 legs just to stand in one place? A singular grounded robotic arm equipped with perfect computer vision and pneumatic suction grips is vastly superior in speed, cost, and reliability.
So why the obsession with humanoids then? Why is all the money going there?
It is heavily driven by venture capital hype and basic human psychology.
Really? Just psychology?
Anthropomorphism is a very powerful force. We inherently relate to and are fascinated by things that look like us. A video of a robot dog or a humanoid doing a backflip will go viral and secure millions in funding because it looks like the future we saw in movies.
Right, it looks like sci-fi.
Exactly. A video of a singular arm sorting boxes efficiently is honestly kind of boring to the general public. But the actual economics of the logistics industry care only about one thing: throughput per hour. And right now, the single-task scissors are winning the war against the Swiss Army knife.
And, you know, that economic reality is forcing major shifts in executive leadership, too. Our sources note that Atoms, which is another rising robotics firm, just successfully poached Gautam Gupta, the former finance chief at Uber.
That was a huge hire.
But why is a robotics firm hiring a rideshare finance guy instead of, I don't know, another MIT roboticist? Because robotics is no longer just a mechanical engineering problem, the physics are largely figured out. It is now entirely a unit economics and capitalization problem.
They're all about scale now.
Exactly. It's about how you fund and scale fleets of expensive physical hardware across the globe. But to build those vast fleets, whether they're walking humanoids or lightning fast sorting arms, you need raw materials and parts. And that brings us to the gritty, messy reality of geopolitics and global trade.
This is the exact moment where the pristine, polished facade of the Silicon Valley tech industry violently collides with the reality of international borders and supply chains.
Collides is putting it mildly. According to a phenomenal report by the information that our sources cite, top-tier U.S. robotics engineers are facing domestic hardware supply chains that are so hopelessly slow and degraded, they are taking matters into their own hands.
They're becoming smugglers.
They literally are. They are flying commercial to Shenzhen, China. They are walking into electronics markets, buying cutting-edge robotic components, actuators, servos, harmonic drives, packing them into their personal luggage, and hand-carrying them on flights back to the United States. And the kicker: Washington literally just passed sweeping bans on new Chinese robot imports last month.
This scenario is almost comical, but it exposes a massive, unresolved crisis in Western technological ambition.
How so?
Well, we have this overarching geopolitical narrative of decoupling. The United States government is actively attempting to build protective legislative walls around its domestic tech industries. They are banning imports, raising tariffs, and trying to stimulate local manufacturing to reduce reliance on foreign adversaries.
Right, trying to build everything in-house.
But the technological velocity of these AI startup engineers is moving at a speed that bureaucratic policy simply cannot contain or understand.
Wait, I need to understand why this is happening, though. The U.S. has the best software engineers in the world. We build the most advanced AI models. Why are our robotics engineers forced to become high-tech smugglers? What is the difference between building a robot in California versus Shenzhen?
It comes down to hardware iteration cycles and the physical tooling infrastructure that the United States largely abandoned decades ago in favor of software.
Okay, walk me through that.
In the software world, if an engineer in Silicon Valley wants to test a new algorithm, they write the code, hit compile, and test it in seconds. The iteration cycle is instantaneous.
Right.
But robotics requires physical matter. If a U.S. engineer designs a new elbow joint for a robot, they have to send the CAD files to a domestic machine shop. Because the U.S. lacks those dense, interconnected hardware ecosystems, that machine shop might take 6 to 8 weeks to CNC machine the part and ship it back.
That's a long time to wait for one part.
And if the part doesn't fit perfectly, that's another 8 weeks. The project essentially dies waiting for metal to be cut.
And in Shenzhen, what's it like there?
In Shenzhen, the ecosystem is so hyper-concentrated that an engineer can design a part in the morning, walk down the street to a manufacturing facility, and have a fully machined, high-tolerance prototype in their hands by the afternoon.
Wow.
The iteration cycle drops from months to hours. So if your entire billion-dollar humanoid prototype is completely stalled because you are waiting on a highly specific servo motor that you can just buy over the counter in a Shenzhen market today, the engineers are going to bypass the geopolitical red tape. They're flying right over the legislative walls.
So if I'm picturing this correctly, the absolute cutting-edge future of American robotics, the proprietary components that will eventually go into billion-dollar Amazon warehouse fleets or home assistants, is currently sitting next to someone's rolled-up socks and a toothbrush in a checked Samsonite bag going through customs at LAX.
That is precisely the reality the reporting reveals. It proves that despite whatever embargoes or tariffs are placed on paper by politicians, the American physical AI industry is still quietly, deeply dependent on the Shenzhen speed hardware ecosystem.
That is wild.
You just cannot legislate a supply chain into existence overnight.
And the hardware smuggling is only half of the hidden backend. Let's talk about the data, because this shattered an illusion for me. Bloomberg reports that thousands of workers in India are currently being paid to manually film themselves doing repetitive tasks.
Yes, the data annotators.
They are generating the training data that will eventually be fed into the AI to teach these exact robots how to automate those very jobs.
This is the great uncomfortable paradox of the entire autonomous AI revolution. It is, at this exact moment, entirely dependent on cheap, manual human labor.
It's not autonomous at all.
Not yet. We have been sold this illusion that artificial intelligence is pure magic, that it just absorbs intelligence from the digital ether. But in reality, It learns through rigorous, painstaking imitation.
How does that actually work mechanically? Like, how does a video of a guy in India picking up a box teach a robotic arm in Ohio how to move?
Through a process called data annotation and kinematic mapping. So the human worker films themselves, picking up a fragile glass. Then, teams of annotators have to go through that video frame by frame. They draw digital bounding boxes around the hand, the glass, and the table.
Just manually drawing boxes.
Yes. They map the exact vector angles of the human knuckles, the velocity of the wrist, the trajectory of the movement. They are translating biological 3D movement into 2D mathematical data points.
That sounds incredibly tedious.
It is. And millions of these annotated data points are then fed into the robot's neural network, allowing it to calculate the probabilities of how to replicate that exact motion with its own physical actuators without shattering the glass.
It is the ultimate modern iteration of the mechanical Turk. We marvel at the machine's intelligence, just completely ignoring the invisible global working class hiding inside the box, manually annotating the physical world so that the AI can eventually replace them.
Exactly. It highlights a massive global wealth and labor disparity in the tech boom. It's a transitional phase, certainly, as eventually robots will learn purely from synthetic data or self-play, but right now, artificial intelligence is built squarely on the backs of very real human exertion.
Speaking of massive geopolitical moves, let's look at what is happening at the corporate and national levels, because the pivoting of resources is wild right now. China has formally announced plans to send quadruped robots, basically highly advanced robot dogs, to its international lunar research station by 2035.
Robot dogs in space.
Literally, they want these machines to mine minerals, patrol the station, and I actually had to read this source 3 times to believe it provide emotional support to the human astronauts.
Emotional support robot dogs on the moon. I mean, if you pitched that in a boardroom 10 years ago, you would be laughed out of the building.
Absolutely.
But from an engineering standpoint, quadruped robots are actually perfect for the lunar surface. They handle uneven, cratered terrain far better than wheeled rovers do.
That makes sense. Wheels get stuck.
Right. And equipping them with LLMs to converse with isolated astronauts shows how deeply physical AI is blending utility with psychological integration in these extreme environments.
And meanwhile, back on Earth, we have BYD, the massive Chinese electric vehicle manufacturer. They are currently facing falling domestic car sales. Their solution: they unveil Shao-D, a 1.6-meter tall humanoid robot, and physically place it in their car showrooms in Shenzhen and Shanghai simply to drive foot traffic.
Just as a draw.
Yeah. And on the American side, Tesla is apparently actively integrating Starlink satellite antennas directly into its Cybercabs.
These two corporate maneuvers perfectly illustrate how physical AI is being leveraged as a strategic weapon.
How so?
For BYD, it's pure spectacle and brand psychology. If consumers aren't coming in to buy cars, you lure them into the showroom with the novelty of a walking humanoid. It sends a subconscious signal to the consumer. BYD isn't just a struggling car company. It is a hyper-advanced, future-forward tech conglomerate.
It's a multi-million-dollar marketing gimmick to sell hatchbacks.
Perhaps, but an effective one that generates headlines globally. Now, Tesla, on the other hand, is solving a very real, critical infrastructure bottleneck for physical AI.
Which is connectivity, right?
Exactly. If you deploy a massive fleet of autonomous cybercabs, their single biggest vulnerability is connectivity. If a robotaxi hits a cellular dead zone and loses connection to the centralized cloud brain, it basically becomes a multi-ton brick in the middle of an intersection.
Which is a disaster.
Right. By integrating Starlink hardware, Tesla is ensuring its physical AI assets have global, uninterrupted, low-latency connectivity beamed directly from space. It is a masterclass in vertical integration. Elon Musk owns the autonomous robot on the ground, and he owns the satellite in low Earth orbit telling it what to do.
Okay, we really need to pause and look at the entire board we have just laid out here. We have optical vacuums mapping the precise dimensions of our living rooms. We have robotic kitchens digitizing our family recipes. We have engineers smuggling physical joints across borders, human data annotators logging every human movement, and cars constantly talking to satellites in space.
It's a lot to take in.
It is. And if you are a tech enthusiast, this sounds like an absolute utopia. But if you shift your perspective and look at this landscape through the eyes of a corporate governance officer or a cybersecurity team, this entire ecosystem looks like an unmitigated catastrophic nightmare.
And that brings us to the invisible crisis currently tearing through corporate boardrooms.
Our sources, particularly this incredibly dense analysis from DeepView, outline what they call the fragmentation problem. Because of this rapid explosion of physical AI, the sheer number of vendors, third-party models, and hardware systems touching sensitive corporate data has multiplied exponentially.
It's out of control.
And the way massive companies are managing this risk is genuinely terrifying. The sources highlight that a company's third-party vendor risk might live in one specific software tool. Their internal IT security risk lives in a completely different siloed system.
Completely disconnected.
Yeah, and the actual compliance evidence, the legal proof that they aren't breaking international data laws. It is routinely scattered across static Excel spreadsheets, shared Google Drives, and basically the fuzzy memories of whoever happened to run the audit 3 years ago.
We have to connect this back to the specific physical machines we discussed earlier.
Okay, let's do that.
Think about the Matic vacuum with its 5 cameras analyzing your home. Think about the Honor phone constantly tracking your face. Think about the Wonder Food Hall AI ingesting thousands of proprietary recipes. Every single one of these physical devices represents a massive, continuous data vacuum.
They are just sucking up data 24/7.
Right. They are not just executing tasks. They are constantly recording video, capturing audio, logging spatial dimensions, and tracking behavioral patterns.
And all that immense weight of data doesn't just stay on the robot. It has to go somewhere.
Exactly. It gets piped back through APIs to cloud servers. It gets processed by third-party large language models. It gets shared with analytics vendors. The data supply chain is incredibly convoluted.
So it's not just one company looking at it.
No, it's dozens. So if a corporation is utilizing a fleet of these physical robots to clean their offices or manage their warehouses, and their risk profile is still being managed by an intern manually updating an Excel spreadsheet, they are functionally blind.
That's terrifying.
They have absolutely no real-time visibility into what sensitive data every single robot is collecting, which third-party server that data is being sent to, or what happens if one of those obscure AI vendors gets breached by a state-sponsored hacker. In a heavily interconnected physical AI ecosystem, a single vulnerability in a cheap sensor can compromise an entire corporate network.
And international regulators are absolutely not sleeping on this threat. The sources detail several new, incredibly heavy regulatory frameworks landing rapidly. We're talking about frameworks like DORA, NIS2, and the sweeping EU AI Act.
And we really need to define what those actually mean for the listener because they represent a paradigm shift in corporate liability.
Break them down for us.
Okay, so DORA is the Digital Operational Resilience Act in Europe. It basically forces financial entities to mathematically prove that their entire technology supply chain, including third-party AI vendors, will not collapse under a cyber attack.
They actually have to prove it mathematically.
Yes, it's rigorous. Then there's NIS2, the Network and Information Security Directive. This is the big one because it shifts the blame. Historically, if a company got hacked, the IT department got fired.
Right, you blame the tech guys.
Exactly. Under NIS2, the board of directors and executive management can be held personally and legally liable for cybersecurity failures in critical infrastructure.
Personally liable.
Yes. If a robotic arm in a sorting facility gets hacked because of a vendor vulnerability, the executives face the consequences directly. And then the EU AI Act demands total transparency into how AI systems make decisions and how European citizen data is protected.
So the regulators are demanding a level of integrated, holistic, unsiloed oversight that most companies simply do not possess right now.
Not even close.
And the penalty for non-compliance under frameworks like the EU AI Act isn't just a slap on the wrist. It can be percentages of global annual revenue. That is crippling.
It can bankrupt a company.
We actually have a perfect high-stakes example in our sources of how volatile and uncertain this space is, even for the tech giants with infinite resources. Let's look at Uber. They just suddenly and very unexpectedly dumped their entire stake in Serve Robotics.
That was a shock to the market.
For context, Serve is an autonomous delivery bot company that Uber acquired along with Postmates back in 2020. They spent $2.65 billion on that acquisition. They had a deep 5-year relationship. And Serve Robotics only found out that Uber was completely bailing on them by reading regulatory financial filings.
That is a stunning level of corporate whiplash. You do not blindside a partner of 5 years unless there is a massive internal strategic panic.
The sources indicate this abrupt split happened over deeply diverging views on how to actually scale autonomous physical delivery operations. The math just wasn't mathing for them. So here's my question to you. If a tech titan like Uber, a company with billions of dollars in liquid capital, elite engineering talent, and a core business model built on logistics is bailing on its own physical robotics investments because they cannot figure out how to safely and profitably scale, how on earth is a normal, mid-sized company supposed to survive the EU AI Act when their compliance data is literally sitting in a static Excel file?
It is the defining question for the next decade of enterprise technology.
Mm.
And the answer lies in what risk professionals refer to as the maturity curve.
The maturity curve.
Yeah. Nobody, not even the Ubers or the Amazons of the world, goes from fragmented, chaotic spreadsheets to perfectly integrated, flawless automated governance overnight. It is a grueling, multi-year process of corporate evolution. Right now, the vast majority of companies are languishing at the absolute bottom of that curve. We call it reactive oversight.
Meaning they only care about the risk after the building is already on fire.
Exactly. They only initiate an audit when a regulator physically knocks on the door or when a data breach hits the front page of the news. They scramble to collect historical evidence after the damage is done. The goal, what frameworks like DORA are forcing companies toward, is proactive governance.
What does that look like in practice?
This is a state where security operations centers are deeply integrated with procurement and IT. They know in real time exactly what data every physical robot and software model has access to. If the EU AI Act suddenly changes a data residency requirement tomorrow, a proactive team can press a dashboard button and see instantly which robotic vendor in their global supply chain is now non-compliant.
Rather than having a team of analysts dig through 3-year-old email threads to find a vendor contract.
Exactly. Uber backing out of Serve Robotics might actually be a prime example of a company ruthlessly assessing its own maturity curve. They likely realized that the staggering risk, liability, and complexity of scaling physical hardware simply did not align with their core software competencies. Managing fleets of physical robots under modern regulatory scrutiny is arguably the hardest operational challenge in business today.
Which leaves us staring at a deeply complex horizon. We have moved from motorized phones looking back at us in the kitchen, to specialized arms dominating the warehouse floor, to the geopolitical absurdity of hardware smuggling, and finally to the regulatory panic in the boardroom. The shift from a digital world of bits to a physical world of automated atoms is happening faster than our laws, our supply chains, or our corporate structures can adapt.
We are frantically trying to install a centralized nervous system into a body that is already sprinting at top speed down a crowded street.
Which leaves us with one final, deeply provocative thought for you to mull over. As these incredible machines become more seamlessly integrated into the very fabric of our homes and our businesses, as they constantly update their capabilities over the cloud, and as they attempt to navigate increasingly heavy, fragmented global regulations, who actually owns the robot in your house?
That's a good question.
Historically, property rights were simple. If you buy a toaster, you own a piece of metal that toasts bread. But if you spend $1,500 on a highly advanced spatial reasoning vacuum or a cooking robot, and that machine suddenly bricks itself overnight because its third-party software vendor in another country just violated a new European data privacy law and had their servers shut down, is that machine really your property?
You're holding a very expensive paperweight.
Right. And if a robot in your living room causes property damage, who is legally liable when the hardware was built in China, the AI model was trained in the US using data from India, and the user agreement is governed by the EU. Are we moving into a future where we no longer own the appliances in our homes, but are simply temporarily leasing physical hardware from a highly volatile, heavily regulated, and fragmented global supply chain? It is something to seriously think about the next time your vacuum stops, turns its cameras, and looks at you. We'll see you on the next deep dive.